You're watching the Target 5.1 retest video. In this target, we're going to solve quadratic equations using a few different methods and then decide which one is the most efficient to use when. So remember, if you're struggling at any specific method, there is a extra practice movie and an extra practice worksheet for you so that you can strengthen your skill before you take the test again. So feel free and use those. But for now, grab your white packet and let's get started. The first piece of this target is deciding which method is the best to use. So I'm going to write the standard form of the quadratic equation here. And for square roots, we're looking for things where the linear term is missing. So you're going to see things like 9x squared minus 13 equals 0. Or you're going to see things that are written in vertex form. Vertex form looks like this. So either one of those is the best, square roots is the best method to use for those. So factoring is another one that you can check quickly. Factoring, if you remember, when you have a quadratic equation, for example, this one, we're looking for two numbers that multiply to be the last term, the constant, and add to be the linear term here. So if you can check that really quick and see if it works, that's also a very efficient way to solve. Now, as soon as you start adding numbers in this spot here, if there was a 3 here or something like that, now it makes it a little bit more difficult. So it might not be the most efficient as soon as that happens. You'll see that in a second. Completing the square, we also use this when the term in front, or the coefficient in front of the x squared was 1, but also that middle term was even. So when this term is even and this term is 1, completing the square ends up being pretty easy too. So that's another method that you can use that's pretty efficient. And for any others, we are going to use the quadratic formula. So let's slide down to some of the problems here, and you can see what I mean then. So this one, right away, you know, they have to be in standard form. So let's switch this one, adding 15 to both sides. And there's a few things that I notice about this problem. The 5 in front of the x squared makes it difficult to factor. There's also the ability that 5 does not go into all three of those coefficients, so that makes it even tougher to factor. So I'm not going to use factoring for that one. I also notice it's not missing the linear term or in vertex form, so I'm not going to use square roots, and then that 5 also makes it very difficult to complete the square. So this one is going to be a quadratic formula problem. And the quadratic formula is this. And the reason why we're going to use the quadratic formula is that factoring square roots and completing the square are not as efficient at this point. Okay, so number 2 then, you notice this one is in vertex form, so right away we're going to do square roots. We'll solve using square roots. Why? Because it's in vertex form. Let's look at number 3. Again, not in standard form, so we're going to write it in standard form. Subtract 10 from both sides. And right away what I see is that two numbers that multiply to be negative 10 and add to be 3 are positive 5 and negative 2. It makes it really easy to factor. So factoring is by far the most efficient method there. Then the last one we're going to do together is number 5. Subtract 10x and add 16 to both sides. And what I see is, again, this one can be factored pretty easy, x minus 8 or x minus 2. Now, some people like the square root. Sorry, completing the square for this one because a is 1 and this b term is even. So I would take either answer for this one, factor or complete the square. Both of them are just as efficient if you're good at completing the square. All right, so let's slide down to the nuts and bolts of the of the unit here and figure out how to complete the square first. So completing the square involved you trying the x squared square and then 10x, and we represented x's by those vertical and horizontal lines. So what we decided was, in order to make a perfect square, we needed to take those 10 and split them into 5. Now we want to fill these with the little squares. So this is a way that you can visualize what completing a square looks like. And if you notice, 25 of them fit into that piece because we're actually completing a square. So how did we get that 25? Well, we split 10 into two parts. So divide 10 by 2. And then in order to get 25, there was 5 by 5, or 5 squared. So 25 goes in that box. So let's do another example, and I'll show you how to get all the way through the problem. So we want to complete the square with 2 there. So 2 divided into 2 parts is 1, and then 1 times 1 is 1. So that ends up being the number that goes there. Completes the square. So this one can then be written as a perfect square, x plus 1 squared. So I think I forgot to put that one up here. Vertex form is x minus 5 squared. And then from there we can solve using square roots, like we've always done. Square root both sides. X plus 1 is equal to positive and negative 3i. And then to get x by itself, we're going to subtract 1 from both sides. We cannot combine the 1 and the 3i, so we're going to write it separate. Remember now, if you need more help by completing the square, there is a movie that it says completing the square, extra practice. There's a worksheet that goes with it too. You can get that worksheet from your teacher or the lunch intervention person. And let's slide on down to square roots. We've got 2 problems here. One of them is in vertex form, so you're going to see kind of the same thing that we just did. Add 5 to both sides. And then since the square is isolated, we can take the square root. And then we'll add 3 to both sides. And when we add 3 to both sides, we have both integers, so we can combine them. So positive 3 plus the 4, and positive 3 minus the 4. 7 and negative 1 is our answers. When the b term is missing, we'll still isolate the x squared. And then we'll take the square root. In this case, it doesn't come out very even. So I can split it into 4 and 5, which means 2 root 5. So the answer is plus and minus, positive and negative, 2 root 5. All right, again, if you need any more additional work with square roots, go to the Square Roots Extra Practice movie and worksheet. That'll give you 10 problems that you can practice that on. All right, let's solve by factoring. This one's number 25. Again, these need to be in standard form. And we're looking for 2 numbers that multiply to be negative 12 and add to be 1. Those are positive 4 and negative 3. And then to get from there to your answer, not quite done, set each bundle equal to 0. We get 2 answers of negative 4 and positive 3. So again, if you need more work with factoring, there's an extra practice video and worksheet that'll give you 10 or 12 problems solving by factoring. All right, and then the last method is a quadratic formula. So the first thing I'll do is write it over here. And then we'll look at each of these problems that are not in standard form. So let's write them in standard form. And then we're able to pick out the a's, b's, and c's. So a is always your quadratic term, or the term in front of the squared. B is the linear term, or the term in front of the letter by itself. And C is the constant term, one without any letters. All right, and then we'll focus on the three different parts of the quadratic formula: the opposite of b, the 2a, and then the b squared minus 4ac. And as you go through this unit, you see the b squared 4ac minus 4ac is the discriminant. We're going to calculate that separate and then throw it into the formula all at the same time. All right, so once we have all of those things, we can go to the quadratic formula. And then we need to do some simplifying. So the square root of 961 is 31. We're not quite done with our answer there. We have negative 1 plus 31 over 6. We also have negative 1 minus 31 over 6. This is 30 over 6 over 5. That's one of our answers. This is negative 32 over 6, which is negative 5 and a third. That's our other answer. There you go. Now notice we could add the 1 and the 31 because they're both integers. Let's take a look at the next problem and see if that's true there too. So the opposite of b is negative 8. 2a is 20. b squared minus 4ac. Okay, and then x equals, back into the formula. So for this one, square root of negative 16, we'll have to simplify that square root. 16 is a perfect square, and then negative square root of negative 1 makes I. And what you'll see is that we can't combine the 8 and 4i because they're not both integers. One of them is imaginary and makes a complex number there, but we can simplify. So notice the negative 8, the 4, and the 20 can all be divided by 4, which makes our final answer negative 2 plus or minus I all over 5. Okay, again, if you need more practice with the quadratic formula, there's an extra practice movie and video. Before you take the test, you probably want to see it. All right, so then look at the last page, look at some word problems here. For the number 37, it's about a picture frame. It's a rectangular picture frame. So it says the length will be 6 more than 3 times the width. So width is W. 6 more than 3 times. 3 times W. 6 more than that is 3W plus 6. And we know the area is 72. So we set up this problem by writing an area equation, length times width. So the length is 3W plus 6. We're going to multiply that by the width, and that's equal to 72. So we can distribute that. So that becomes 3W squared plus 6W. A lot of people forgot that second W there in the test. And then we'll move the 72 over by subtracting 72 from both sides. And we'll divide everything by 3. Take out a GCF. And if you notice then this one, two numbers that multiply to be 24 and add to be 2 are positive 6 and negative 4. And when we solve, we get W equals negative 6 and W equals positive 4. So right away, we know that this one can't be true because we have negative width, which leaves us with dimensions. The width is 4 inches, and the length is 3 times 4 plus 6. That makes 18 inches. Final answer. All right, notice we used factoring in that one. That's the one I checked first. It's the easiest one to do. Let's look at the last one here, number 41. So Jared's kicking a ball over a tree. It's 50 feet tall. The height of the ball can be modeled by this function right here. How long is the ball in the air? So if we think about this, the ball is in the air, it's coming back down. We want to find that time right there. Well, that's one of the solutions. Here's the other one. So we want to find that time, which means we want to solve this quadratic equation when the height is 0. So 0 equals negative 2t squared plus 20t plus 1. So notice that there's that negative 2 in front, which makes it really hard to factor or complete the square. And since it has a linear term, we're not going to use square roots. So let's go into the quadratic formula. A is negative 2, B is 20, C is 1. So the opposite of B is negative 20, 2a is negative 4, and b squared minus 4ac is 400 plus 8, 408. The quadratic formula then looks like this. Okay, so now since this is a word problem, it's going to need to have some it's got context to it. We want to have decimals. It's kind of like this speed limit sign. You don't want to put like root 3 for your speed limit. You want to give me a decimal for that piece. So using my calculator, I'm going to calculate the square root of 408 and use that in my calculations. 20.20. So really we have negative 20 plus or minus 20.20 all over negative 4. And that is two answers, negative 20 plus 20.20 all over negative 4, and negative 20 minus 20.20 all over negative 4. Negative 20 plus 20.20 all over 4 gives me an answer of negative 0.05 the seconds. That's before the ball is thrown. So that doesn't tell me how long the ball was in the air. And negative 20 minus 20.20 divided by negative 4 gives me an answer of 10.05 seconds, which is how long the ball is in the air. All right, there you go. If you need any more help, go see your teacher. Long movie, but there's a lot of stuff in it. So remember, you need to have this packet done before you start retesting.